Yes, sir. We are in live right now. So, good evening to the participants. Most of the participants are from India. And good morning to Jim Cantrell, sir. This is a good morning, and it is a great to have you with us right now. And surely our students will be going to get some knowledge from you. And India will also make so many entrepreneurs like you to develop space launch systems, sir. And I request Dr. Nehru, sir, to give a welcome address for the guest as well as to the participants.
Thank you very much, and welcome you all to the session. And I would like to thank TEMS Academy for giving us this opportunity to participate. And first, I would like to give a small, brief introduction about Jim Cantrell. Jim Cantrell is the founder of several entrepreneurial startups, including Vector Launch, Rat Space, and Vintage Exotics Competition Engineering. He was on the founding team of Moon Express, private company attempting to land on the lunar surface, and on the founding team at SpaceX, where he was the first vice president of business development. Vector developed affordable small launch capabilities aimed at the micro spacecraft market. StratSpace has a long history in pivotal technical and financing roles in the aerospace industry's most influential and innovative players. Jim's career also included assignments at the French Space Agency, the NASA Jet Propulsion Lab, and has resulted in experience in over 46 satellite flight missions, including the Iridium Next Space telephone system, the LightSail solar cell mission, and OSIRIS-REx, which will return asteroid samples to the Earth. Cantrell is a world-recognized technical innovator and has received numerous professional awards. He is the author of 20 technical papers and has pioneered the concepts of software-defined satellites, micro-launch vehicles, as well as space situational awareness sensors. A mechanical engineer by profession, Cantrell also actually participates in road racing. In the year 2005, he founded Vintage Exotics Competition Engineering, which designs and restores race cars. Vintage Exotics continues to field an endurance race team and competes in amateur and professional race series. Jim speaks 4 languages and spent several years each working in France and in Russia, as well as on joint US-Russian defense programs. Jim has held positions with NASA, the French Space Agency, CEO of Vector Space, CEO of StratSpace, CTO at Moon Express, President of United States Launch, President of Vintage Exotics, and CEO of IDAir, a biometric software company. Jim serves on corporate boards for aerospace manufacturing companies and the Sports Car Club of America. He holds board of advisory position at the Planetary Society, at Space, Morphe of Space Systems, and ICA. He resides in with his family. Thank you all, and once again, I would like to welcome Mr. Jim Cantrell. Welcome you, sir. So
Thank
we are
you.
all excited. We are all excited to hear from you. Over to you.
Thank you for your warm welcome and long introduction. So, yeah, I just as a side note, worked with the Indian Space Agency on IRS-1C back in 1995. We co-launched with them out of Kazakhstan. So, have been to India and met with the Indian Space Agency to coordinate that launch. So it's been an interaction with them. I've enjoyed it. So what I'm going to talk about today is the space transportation system and where I think it's going and where I think ends up putting people in space and how I think that'll end up in the future. Let me get this up for you. And take a minute. All right. Okay, I'll give it just a second to catch up with this. Okay, so this is what I call the launch revolution. And you'll see why I call it a revolution in the course of my talk. I think that we on the cusp of something that is very magical. It's significant. See, the launch industry, the transportation industry, looks a whole lot like the automotive industry 100 years ago. If you go back to Detroit, which was arguably where the auto industry began 100 years ago, up 80 companies that were building cars, but you began to see the seeds of what became General Motors and Ford Motor Company, Chrysler, and some of the other car less in that time period 100 years ago. If you look historically where we're at today, that's where we're at in terms of the launch industry. And so I'm going to try to talk a little bit about where I think it's going to go and the directions I think it's going to go. So let's stand back and let's talk about something a little more terrestrial. Let's talk about where we live. And this is a picture of the New York City skyline circa 1876. So this was 150 years ago almost. And you notice something if you've ever seen pictures of New York City or been there. You know that it's a much higher skyline. There's very tall buildings and so forth. But in this time and era, people didn't build big, tall buildings, mainly because humans had to live in those buildings and there was no way to efficiently go up and down without elevators. And so in that period of time, the real estate became very crowded, but mainly with small buildings for that lack of technology. Today, we know it to be something quite different. It's very tall. It's grown vertically. If you want to think of it, the real estate in Manhattan has grown upwards towards the sky. And it's all been because of one technology, and that's the elevator. And I think the same analogy holds in space. And I use this as an analogy for space commerce. And we all know that governments have been keenly interested in space for many years. But what's new in the recent years is the interest of commercial entities and investors in putting money into space. And in many ways, they see the same thing that we see here, which is commercial potential, and that the economy, much like New York City, will have many layers, and those layers will reach into space and efficiently move between those layers. So really appropriate to think of launch system transportation as our future's elevators, and that they will serve much the same purpose. And let's talk then about what we see for tomorrow's space commerce. And I think there's a fundamental transition underway that is mirrored in the terrestrial economy that we just haven't seen in the space economy. Today, space is very hardware centric. It requires a lot of money to get a space company going. Rarely do you find a space company that can't be started for less than $10 million. Usually takes years to develop. And this is much like the computer industry was maybe 40 or 50 years ago. It's still very much that way. It's still very backwards in a lot of ways from the terrestrial technology economy. So tomorrow, I see a future where everything becomes software centric in space. And by extension of that being software centric, the amount of money to start a space company will drop dramatically, and it will be done in very, very short periods of time. This will require both in the satellite technology we use and how we build it, plus the space transportation. We can build all the satellites that we want, but if there's not an efficient way to get the hardware into space where we want and when we want, then tomorrow will always be yet another day. And so really we have to master the launch systems and the space transportation system first. So oddly, what is driving is a budding revolution in launch technology actually comes from the satellite side. And what's disruptive is the size of satellites. You can see on the right, microsatellites, which I believe you probably all are somewhat familiar with, are sometimes the size of a loaf of bread or even a can of Coke. And whereas the older satellites were much larger, the size of a bus, size of a train, with a lot of money and a lot of time. So the microsatellites that have come along over the last really 10 years, maybe arguably 20 years ago, are actually revolutionizing launch because there's so many of them, and they're getting so small and sophisticated enough they require individual solutions for launch. So here you can see a trace the mass of the satellites over the years, starting with about 1993 on the left, up at roughly 28. And I guarantee you continues. What you can see is the top line, which is really the satellite's geostationary orbit, and they're about 5 to 10,000 kilograms. And those will always be there because geostationary orbit is kind of like beachfront property in Hawaii. It's not a place where you build a small little house. It's so valuable you build very large buildings to make the best use of that expensive property. So geostationary orbit only has so many slots available. Therefore, the satellites that tend to go there tend to be 30-year assets and very expensive and very large. So that drives not only that market, but it also drives a continual need for very large launch vehicles, and that will always be there. But on the other hand, you start to see the continued bifurcation lights into small. The small is 1 gram, which is maybe what you might eat for lunch or dinner, and it's very, very small, very capable that we find today in these areas, and this will continue to grow, and this history of trends will continue to densify in the smaller launches. Something on the order of 400 small satellites were launched last year with the COVID virus and so on. I think the market's going to take a breather for a few years, but it's going to come back. And I think all the original predictions of 800,000 satellites still there. So any change in long-term prediction, because the market forces are very strong in that direction. Everything gets cheaper the smaller it is, and so there's a lot of financial motivation, and the technology keeps developing and enabling this. So what we're finding is commercial satellites now are being made by the hundreds. This is the Planet Labs satellites. I worked with them for a time about 5 years ago, and until about 6 months ago, they had the largest constellation in operation in the world. However, SpaceX Starlink satellites and the fact that they also owned launch were able to create the largest constellation and become the largest satellite in the world within about 6 months. It was very, very quick. So this trend will continue because there's an ability for large numbers of these satellites to do things that simply the single or low number of larger satellites cannot. And it's due to the fact that the satellites are spaced widely apart in orbit, and you have a density of them, so you can observe all places on the globe at the same in real time. You can do that with small constellations. You can't do with larger satellites, as an example. So what Planet Lab has managed to do with their constellation has created what I call a living, breathing Earth image cloud. And this gives us, for the first time ever, a sense of our planet, of our Mother Earth that we've never had before, and how it changes on a daily basis. And despite the sort of it, enormous economic value that derives this. There are people who are using these images to things like oil capacity in the world, how much oil is in all the tanks stored around, how things are changing, how agriculture is changing, how the climate's changing, traffic, ship traffic, illegal fishing. There's just an endless number of things you can do with good quality imaging from space. And if you bring that cost down, that will open up that resource to more and more people in the world, and more smart people looking at this will come up with better ideas. So this is a exponential growth industry that I think is just beginning to start. I can tell you one of the other things I'm involved with the Planet Lab imagery was monitoring North Korea. And you might think the United States has such a capability to fly satellites that see anything that's going on anywhere in the world. That's not necessarily true. One of the issues with a single satellite that's looking down is if its position is known, then all you have to do is hide when the satellite is over and then resume what you were doing before. So during the period about 6 years ago, we in the United States were not able to predict when the North Koreans were going to set off a nuclear weapon or launch a rocket. And our politicians were embarrassed because they couldn't predict this. And so I began working with a guy in the Pentagon who asked me about using commercial imagery to set up a neighborhood watch program over North Korea using the Planet Lab satellite. And for something like $10 million, we were able to predict what the North Koreans were going to do with their missiles and with nuclear tests, where billion-dollar satellites couldn't do it. This is the power of commercial space, and why I believe that government space and commercial space are linked together forever, regardless of what country you're from. I can also tell you that this is the only human object of interstellar voyage yet. It's solar sail. This is LightSail 1 and 2. I was one of the inventors of this. I worked on it, and it finally launched last year very successfully. You can see the four of us up on the right in the red shirt is Lou Friedman, who was one of the founders of the Planetary Society, and it was really his idea, along with me, to use CubeSats, and then Tom Svitek in the striped shirt in the middle. He came from Czechoslovakia in the 1980s, and we first knew him as a student at Caltech. He helped us build the satellite, and then the mysterious man on the left is Richard. He was the person who put the money up. Private citizen, wanted to do good things, and he loved the idea of interstellar spaceflight, going to other stars. And so that's why he funded the LightSail, because we could theoretically put a laser on it and send it to the stars. So that was the beginning of this voyage. It's, as Confucius said, first step in a 1,000-mile voyage is one step. So let's talk about the transportation system then. When I say a transportation system, you're normally going to think of these things. You're going to think of everything from walking to buses to boats to trains to public transportation system, to individual cars, even aircraft. And this is the world we live in, where these things are, depending on where we're at, mostly available to us, and mostly available to citizens in large cities and so forth. But really, we forget to talk about the space transportation system, which is a new part of it. And it's merely extending what the aircraft does, which is to leave the surface and to go from point to point faster and more efficiently. And so I view the rocket really as being the new aircraft. And again, aircraft have been around 100 years, rockets about 50, and we're currently behind in terms of the development and so forth of the rocket compared to the aircraft, but that will come. So just a reminder where we've come from. I'm mid-50s now. I sat on my grandfather's lap and watched it happen live on TV. And it was something that was an awesome event for all of humanity. But it was clearly something that was a demonstration that only nation states could engage in. Nation states had the money and the resources and the will to do this. And this in 1969, a contest with the Soviet Union, and really it was a proxy contest of the power of the Soviet Union in the United States and communism versus capitalism. But that extended to the 80s. We decided to continue human access to space on a long-term basis in the United States. This is probably one of the most magnificent flying machines ever. I've walked through both the American shuttle and the Soviet shuttle. These are complicated machines, very expensive. The cost per each shuttle was close to $1 billion. That's not the cost of the shuttle, that's the cost to launch it. But clearly, this is a nation state level activity. Private companies are doing some amazing things, and I can happily say I was there at the birth of this new private revolution. I didn't realize it at the time. None of us realized it at the time, but few of us saw this outcome. I believe Elon did, and it was his belief in this outcome that really made it so. It's proof that, few individuals can make a difference in the outcome for humanity. And it's very inspiring, that message. And I think that is part of what draws people to Elon's story. And it's the magic of it, really. And this clearly was not all Elon. It's clearly a team of very talented people. But nonetheless, this is a vision, reality. And just a few weeks ago, as you all I'm sure know, SpaceX made history in putting the first humans into space on a private rocket. Again, not what we envisioned when we started SpaceX. It was certainly in the discussion, but it was never in the hard planning, I can tell you. So 20 years, it's not been quite 20 years, it's close to 19 years ago, Elon called in July, and his original idea was to send mice to Mars as an example of why humanity become multiplanetary. And we talked him out of that and into a plant growth chamber on Mars. And familiar with the story, we designed that. I got the Mars Pathfinder team together, along with some other of my colleagues, designed a mission for him, figured out which Russian vehicles would and we went over to Russia to buy those vehicles to actually do this mission, and it wouldn't easily to Elon, and Elon didn't like the Russians, and so that's when we decided to build a rocket ourselves. So 19 years ago, that was an absolutely insane idea. You can imagine how insane it seemed at the time. Now it as a different reality. And this is my point I'm making to you, is these realities change over time. And I can remember in the early days, Elon would show me designs for a Mars base. And I would tell him, hey, it's hard enough to convince we're going to build this rocket ourselves without the government, and let alone to talk about doing bases on Mars. Clearly, Elon stuck with that vision, and it's coming. And that's a really inspiring. So tomorrow, I truly believe private citizens will be doing this, going on space tourism. I think space tourism, in fact, is not the main reason why commercial space will exist. I think it will be a very newsworthy kind of story because of the human interest, but it's not going to be the primary economic interest for a while. Maybe 50 years future, yes, but the 50 years are going to be dominated by, let's think of it as the equivalent of the internet in space. And it's how we pass bits of data more efficiently on the Earth, gather photons from space to create economic value. Later, evolving the space transportation system, exploitation of other worlds is a definite possibility, and it's one I've long believed in and think it will happen. So, when I was a young kid, I was a huge Star Trek fan, and you were either in my neighborhood, we were either a Star Wars fan or a Star Trek fan, and you had to choose sides, and you couldn't do both. So I chose Star Trek, and I liked James T. Kirk. I thought he was a brilliant leader. When I see William Shatner still on TV, it evokes that sense of admiration of that character. To build the Starship Enterprise. This is what I went to engineering school to do. It's what I imagined. I knew it was far off, but this is the imagination of a child, and these things are important to keep as you go through your engineering education. They're important to feel that inspiration, because actually doing these things is very hard, very unforgiving. There's always something like this that inspires us to go into these very, very hard industries and make progress. Launching stuff into space is very hard. It's energetically very intense. There's a lot that can go wrong, and almost anything that goes wrong will result in a loss of mission. So it's very fault intolerant. In many ways, this is the cars I race, where you have a human, and often it's me inside the car driving at very high speeds in confined areas, and if something breaks or goes wrong, very bad things happen. So I have become used to living in this world of a failure, but it is not simple and it is not inexpensive. However, there are ways of making these things more reliable, less expensive, and more commonplace, which has clearly happened with racing, for example. Back in the 60s and 70s, it was not uncommon during a race for somebody to die. Today, it is very uncommon for people to die because of improvements in technology and safety, and generally the rules have tightened up on this. Same is true of launch. I think the Falcon 9 has something like 5 launches, or it's getting very close to that. and flight of a Falcon, and that's a pretty impressive flight record. If you look at it, the Delta II was about the closest to this, was of that number, and they had lost something like 4%. So this is being up on 1%. It's a testament to both the team, but also the technology that evolved around launch. So the other thing about launch, very capital intensive. And this is a space shuttle main engine, just as an example to show you how complicated they are. I won't go into all the complicated machinery at the top, often millions of pieces in a rocket. The space shuttle itself was 2 million pieces, roughly. The Falcon 9, about 60,000 pieces. When you get the parts count down, both the cost comes down and the reliability goes up. One of the things you have to think about is, if you have to spend a lot of money on anything you're doing and it's somebody else's money, they're going to evaluate the risk of what you're doing. And the immutable law of investment is that the lower the money, the higher the risk people are willing to take. And the higher the money, the lower the risk people are going to take. So you'll know this in your own life. You might be willing to risk a few dollars on something that's a very low probability of working out, but you're less likely to spend $10,000 something that's unlikely to turn out. So the same is true in investing. It's no different. And so one of the things that we have to battle in the space transportation system is getting that cost down. So the thing that is not happening is that we aren't thinking of space transportation like we think of public transportation systems. In a lot of ways, there's a lot of similarities. If you look at, say, the rail system, for example, you have something that's very capital intensive. To lay those tracks is a lot of money. To develop the trains and operate them is a lot of money, but it carries a lot of people, and they also have to be transported safe from point A to point B. So it's likewise just as fault intolerant as rockets. And so there's a lot to learn from that. It serves a purpose. However, it's not the only form of transportation in the system. Rail, for example, there's a place, I think, in the future for rockets eventually to be part of that transportation system. There's openly discussion of Starship, which you're probably familiar with, being developed by SpaceX, to go point to point on Earth. If you look at the size and costs of Starship, if they achieve those targets, you'll be able to transport a kilogram of freight from New York City to Japan for the same cost that it could be done with rail if you magically had railroad tracks that would go all the way to Tokyo. So it's important to think of the space transportation layer as not only just for putting satellites up, but it might also be point for freight. It might also be point to point for humans. We just don't know where this goes. So space will become another part of that transportation medium where people and commerce passes through, as well as goes to remain to do commerce or to live. So the automobile is really what we might call bespoke transportation. In other words, it is made for a specific purpose, individuals, to go from point A to point B, where those points are not on a public transport system. And even the idea of point-to-point rocket would be probably from large places like New York City, where you had the infrastructure to support the takeoff and landing, to another place that had it. The automobile is to the train as small rockets would be to big rockets, where you can go where you want when you want, and that's the main selling point. And ironically, there are far more cars in the world than there are buses and trains in airplanes. So no surprise there. And amount of sheer quantity of automobiles that have been produced have reduced the cost of what amounts to a very complicated machine, very sophisticated technology, and it's now becoming more reliable than they were 30 years ago. And it's become the standard mode of transportation around the world. This was all started by a guy named Henry Ford, and Henry Ford had failed a number of times. The Ford Motor Company was his last and successful endeavor, but he had this idea of building cars cheaply and being able to sell to the common man. This was despite the fact that Henry Ford, by all accounts, was a son of a bitch. He had a pretty noble idea in mind, and he thought he could make a lot of money on it, which he did. But 100 years ago, when the Model T was first being thought of, it was something that really nobody else was doing. In the time, cars were about $8,000 in linear dollars, and they had to be operated by very special operators. And Henry Ford came along and said, we're going to build cars that we can sell for about $400 and that my employees can afford them. And he did this through mass production. And this is an interesting comparison to, I think, is going to happen in the space industry. So production was very simple. It was an assembly line where everything was made the same. The famous Ford saying was you could have the car in any color you wanted as long as it was black. This made it easier and simpler to produce the cars, therefore reducing the cost. But the other side effect, which was substantial, was that cars became more real, became so people began to understand and could repair them even later as they became an experience in early. I think our equivalent in space is the next generation of micro launchers. And, there are a few out there that have flown, the Electron and the orbital Pegasus, for example. There are a few that are up and coming still, but these are equivalent of the automobile in the launch industry. They can take satellite or your payload to any orbit at any time, and there is definitely a market segment that prefers this over large launch. Large launch, particularly reusable large launch, is targeted again at very satellites and transporting people. That's where it's economically most efficient. There are costs associated with riding on those large vehicles if you're a small satellite doing rideshare that aren't accounted for in the price, and opportunity, cost of time, ability to on your schedule, and access to unique orbit will be more and more important with the market as time goes on. And we've seen this. I've been in this business for 30 years, and I've seen this time and time again. And I think that this is a market segment that is here to stay, despite the fact that there are 80 or 90 competitors. I think COVID crisis is going to wipe out a good number of them, but there's probably room for 5, 6 worldwide, maybe more later. Just like there are automobile manufacturers in the world. And I think that analogy really holds strong. So there's some really competing approaches that I want to talk about then. You've got really two sort of ends of the spectrum on cost. You've got large reusable launches, as SpaceX is doing and doing very well. And then you have small launch that's high rate, meaning hundreds of them a year. And again, using the analogy of the Model T, this is how you get the cost down, the reliability up. And I believe eventually small launch will have to be reusable, or maybe recoverable is the right way to put it. simply because dropping your first stage on the Earth, whether it's over water or on the Earth itself, is not a sustainable model, not just from an environmental perspective, but more where you launch from. In the United States, to launch, you must launch out over water because of the probability of hurting somebody. And you can't launch from, say, Yuma, Arizona, which is landlocked. But an aircraft, a 747, can take off out of, pick an airport, I don't know, Miami, and you can fly out over the city with 400 people on the aircraft and far more fuel aboard the 747 than a lot of these small launchers. So if you can master recovering the first stage booster, chances are we'll be able to launch these from anywhere on the Earth where there's sufficiently low density of population, or maybe even high density. But eventually, the right-hand column has to all have reusability, and that large will go for humans and large satellites, small will go for primarily small satellite commerce. Anything that's got low rate launch, I think, becomes too high cost and becomes something that will die with the dinosaurs. So I think that's how to view this industry. And the other thing that happens is when you reduce the size of the vehicle, you get an exponential reduction in costs. We all know from our experience that costs are a fraction of the weight, they're a function of the weight, and the less weight, the less cost. And the SLS, which is NASA's Space Launch System, the estimated launch cost, just the cost on it, is about $3 billion per launch. And some of the smaller launchers are in the single $1 million range. So there's a huge difference in this cost. And so there's an economic incentive to be running the smaller vehicles, which if they're made in mass, they can actually be economically competitive on a per kilogram basis with the large vehicles. And that's what this chart shows. These are some example small launchers and micro launchers that have a cost per kilogram on the vertical axis, and then the horizontal axis is the size of the vehicle in terms of kilograms to orbit. And you can see that if you get in the 200 to 1,000 kilogram, you can be every bit as cost competitive with the large reusable launchers like SpaceX. So there's the high volume production enables something called the learning curve. So every time you build another one, the cost comes down. We know this from experience with automobiles, with aircraft. Anything that's a complicated machine has this effect. And so due to that effect, this is how small, reusable, mass-produced vehicles can be every bit as cost competitive as large. There will probably never be thousands of large vehicles flying a year, I don't think, but there probably could be thousands of small vehicles launching simply because of the capacity of the market. So you don't have to mass manufacture rockets, small ones. You don't have to build a huge capital intensive market. You can just mimic what was done by Ford in Model T and use moving station line assembly. Rockets are put together today, even SpaceX, much like they built Maseratis and single unit cars in the 60s, where the car would sit in one place and the parts came to it, and you'd have one to put the car together, and then when it was done, it would go out the door. Whereas today, the Maseratis run through the factory, much like the Model T did. And that's all you need to do, really, in terms of manufacturing that technology. It's really very much a today technology. Nothing new has to be invented there. And no new infrastructure is needed. You can mobile launch these small vehicles very easily. And the other sort of thing to think about is something that's recent. And in India, I'm guessing, I haven't been there in a number of years, but I'm guessing micromobility maybe is taking off in India. And it's a phenomenon I became aware of about 2 years ago at an automotive conference in Germany. And there was a very smart man who gave a presentation on how micromobility, little scooters, electric bikes, where you could put your credit card in, rent them, go to your destination, drop it off, and then somebody else pick it up later, would take off. And so this is sort of an interesting modern version of the Model T in a way, in terms of its analogy to the launch industry. So I think of this in a very similar way. And one of the interesting things about this is it's spread very, very, very fast. And Uber and Lyft were a different sort of thing, but they moved very, very quickly in terms of adoption. And as well, the e-scooters have moved very, very quickly in terms of adoption. And this has been because the technology was readily available, the market was there, and it just had to be capitalized. And I think a similar thing will happen once we get past the barrier of a few of these launch vehicles actually being mass produced. So this will create a new transportation model where hundreds of flights per year can be had for single-digit millions of dollars, where we're still going to be looking at tens, maybe 20s or 30s of the SpaceX flights per year at 60 to 120 million dollars a flight. So it'll be just a different economic system. And Rocket Lab has done a very nice job of this so far. They were the first ones to market. It'll be interesting to see how they fare long term. They're a little bit expensive on the price point, and they really weren't designed to be mass manufactured. Even though that was the desire of the company, the design is inherently difficult to manufacture. They may evolve it in ways that will change that. I hope so. But they're the first ones out of the gate, as we like to say. So gears here, go back, then I think the most important revolution on Earth has begun. That is our leaving Earth and becoming, once as multiplanetary. And we've taken our steps off of Earth. This is an astronaut whom I knew when he was alive, Bruce McCann, flying the famous NASA jetpack in space, a flying human in orbit, really, human satellite, if you will. Just a magnificent technology, and really first steps off of the Earth. But it's clear that we'll move into space as humanity, much like how private citizens settle this part of the world. And it was not government that really settled this part of the world. It was individuals who left their home countries looking for a better life, looking for a new life, looking for opportunity, and so forth, that settled this really hostile place that used to be in North America and turned it into a civilization. That same model will serve on Mars, which will obviously be the first place. And it'll be led not by governments, but by private citizens. Because the government, I think you can see now by the way things are going, government can't do it alone. The government will always have a role in space because the government has missions that involve space, whether it's defense, whether it's space exploration, whether it's science. There's always a legitimate government mission in space. But in the old days, when we built the rockets by NASA, we built the spacecraft by NASA, and so forth, those days are over. What we saw with SpaceX a few weeks ago is going to become the new normal. And the other thing we have to think about is that fortunately our battles and schools are going to make their way in space. As we start to do more and more commerce in space, that becomes an inviting target for our adversaries. And so we have to think of these things and recognize that space will not be uncontested, and this will be where governments get involved So this part of the future, I hope, is not as dire as it could be, but we have to all pay attention to it. So while the rest of the world is doing this right now, we're worried about COVID, we're worrying about all these other things. Those of us in this business, we continue to seek going where nowhere else goes, and we're just continuing to push forward, and that is what our DNA is unfortunately for us and our families telling us we have to do. So this is what we do. Just sort of looking back a little bit, this was SpaceX. This was the first 3 weeks of SpaceX. I took this picture in the early days. That's Elon's McLaren there. And you can see the air compressor that we just bought. And this was where we built the Falcon 1. Eventually, we painted the floors, cleaned it up. But the insulation on the ceiling was falling in. It was hard to imagine that the revolution would start here. It just didn't seem possible. But yet it did. And it did it because of some inspired people and determination and ability to find money to fuel these dreams. And it became this. And it's just an amazing thing. Just an amazing thing. And to have had a small part in this is one of the most humbling things in my life. So that, eventually, I believe that SpaceX will be the first humans on Mars. Maybe it's Elon himself. Maybe it's Elon in combination with NASA. I don't know. But I'm pretty sure that SpaceX will be the first ones to land on Earth. And that will be, or on Mars rather, that will be a magical moment for sure. And I believe that, like Elon's early ideas of Mars bases, and like the movie The Martian, they will build places to live. They will figure out how to survive in what amounts to a very hostile environment. Myself live in Tucson, Arizona, where it's a desert, very hostile desert. We have rattlesnakes. We have creatures that want to eat me. They want to eat my dogs. They want to cause harm. Yet we've lived here for a long time, and we find ways to adapt. And humanity will do the same on other planets. And I want to leave you with an idea here that I know who the most famous human ever is, but yet this person's probably not born yet. This will be the first human going to be born not on Mars, and that will be a symbol of our evolution as humans into the cosmos. And it will happen someday, I guarantee it. And maybe during my life, maybe during your life. I certainly hope so. But it's inevitable, and it will happen. And this will be, I think, the ultimate expression of our human achievement and our human liberty. And it won't be a government program, which I think is something to smile about. So this picture of Starman on his way to Mars in a Tesla says it all for me. And this is the message I want to leave you with, that we've got a very, very bright future ahead of us. All of you are young. I'm getting into the sunset of my years, and hopefully we've left you with something that you can build on, because we all build on our predecessors' achievements, and we stand on their shoulders. So thank you very much, and I'm happy to answer any questions any of you have.
If any questions are there, they can type in the comment box or in the chat box. I will convey that to Jim Cantrell, sir. So, first question is, do you think artificial intelligence mission control can help to reduce the cost and increase of frequency of launches?
Okay.
Yes,
I want
sir.
to see if I can. I want to see the chat. Is there?
Yes, sir. You can
Wait.
see in the chat.
Where is it? Okay. Can you? Oh, there we go. All right. Do you think artificial intelligent mission control can help reduce cost and increase the frequency of launches? Absolutely. It certainly is not the solution to everything. Taking human expertise and creating a machine intelligence that reflects that is, been demonstrated time and time again as a way to do that. In fact, this is an area of interest for me personally because the fueling of rockets and the launch and the if you watch, for example, 2 weeks ago when they were launching the astronauts, they had to go around and ask everybody, "Are you ready for launch? Go, go, go." You can automate that if it's humans. That
Okay, sir.
But
Hello, sir.
yep.
Yes, sir. From Nehru, sir itself, what motivates to innovate?
Right.
Sir, what motivates to innovate?
What motivates me to innovate? The pleasure of innovation. It's one of those things where you have to have a reason to live, and for me, building things is my reason to live. So it's really that simple. It's just something that brings me great pleasure.
One from Raghavi, she asked about, sir, is there any possibilities of human survival in Mars?
Well, we don't know about if humans can survive on Mars without health problems, but I believe so. I believe human will adapt. We'll find ways to overcome health problems that may happen from different gravity and so forth. But I can guarantee you, once we start going to Mars, people will be victims of things going wrong. So people will die, unfortunately.
Okay, sir. One of the question from HOD Aerospace Department: which size falls under nano category? Which size falls?
Nano. Yeah, generally we say nano is under 10 kilograms. Small under 100 kilograms. Everybody has their own definitions, but that's kind of where I think. And micros 50 to 10, something like that.
Okay. So another question is from is SpaceX planning to build separate space station?
I'm not aware that they are. If they are, it would be a secret, which Elon's very big on keeping secrets, but I don't see any evidence of it in the type of people they're hiring and so forth. And I don't see a lot of use that they would have for it in where I think Elon wants to go.
Okay. One of the question from student itself: how did you recruit the team to build Falcon 1?
Good question. So they were all colleagues that I knew through the years, and we just recruited through people we knew. And for example, Gwen Rotwell, who runs SpaceX now, she replaced me when I left, and I had known her for a number of years. Tom, the propulsion guy, Tom, heck, I forget his last name already. He was a friend we'd known forever. Worked at TRW, and it was mainly this circle of friends.
Okay, sir. And many of the followers in the YouTube also, they are asking, is there any internship opportunity to work as an intern with SpaceX?
Yeah, I get this question a lot, and I'm sorry to all my friends in India and Pakistan and another country. We have laws in this country that don't allow non-citizens and non-residents to work in aerospace. And comes from a long time ago, but yeah, it's very, very difficult for us to except foreign students.
Okay. Another one is if Crew Dragon will be successful, whether the space tourism will be possible or not.
Let me see. I'm trying to find that question.
Sir, one second. In the last, sir, in the last, if Crew Dragon will successful.
I'm not seeing the question. Is it after logical thinker?
Not logical thinker. It is below that. Below that.
Yeah, I don't see it. Okay. For some reason,
Okay,
it's not coming up.
No issues. That
you repeat the question, please?
if Crew Dragon will successful, then space tourism is possible or not?
Yes, it is possible. It's been going on with the Russians for some time. I think it's a limited market. I really believe that. I don't think that the cost of space tourism is going to come down to the kinds of levels that you and I can buy aircraft tickets to go to India or come to the United States for. So the average person is not going to be able to afford it. And it will be, for our lifetimes, I think, the domain of the wealthy. I could be very wrong, but it certainly is possible.
Okay. Another question from Happy World. Why are we not using solid fuel reusable rockets?
Solid fuels are simpler in a lot of ways, but they're more complicated to handle from a safety point of view. At least in the United States, because of safety protocols, they tend to be more expensive by a large amount. So for reusability, that was done with the shuttle, with the solid reusable cores, and our experience with that on the shuttle was not positive in terms of the cost. It probably would have been cheaper to have them expendable in that case.
Okay. Can we expect a long-range space shuttle exploration?
I'm sorry, say again?
Can we expect long-range space shuttle exploration in future?
Long-range space shuttle exploration?
Yes, sir.
I'm not sure I understand the total meaning of that question. I don't think we'll see space shuttles flying again, like we saw, with the Soviet and space shuttles that stay up in space for a long time. We have the X-37 that's mainly unmanned, so there could be, I think, a military use of these, but I'm frankly not aware of any plans whatsoever for that.
Okay. So we can have the last session since you are not having much time. So the last question is how intercommunication with constellation of satellite works.
Interconnection within a constellation, typically, like on Iridium, which I worked, we had L-band RF communication between the satellites, cross-linked. I think the future will have optical communications between the two. That's what I'm starting to see is optical communication links becoming more normal because of the RF spectrum issue. There's limited spectrum you can use because of interference on the Earth.
Okay, sir. Okay. Sir, with this, we can end the session. I request Dr. Dharmender Singh, head of the department, Chandigarh University, to give the vote of thanks.
Thank you, Chair.
My pleasure.
Thank you, sir. I feel proud and privileged to present vote of thanks. First and foremost, I would like to thank Mr. James Cantrell, SpaceX National Council Science Museum, Government of India, Director of Kurukshetra Panorama and Science Center for their participation, and last but not least, I will thank all the participants who have joined to and made this webinar very successful, and I interacted with the co-founder of SpaceX. Thank you very much.
My pleasure.
Yes. Jim Cantrell, sir, it is a great to interact with you, and we are very much thankful for spending your much valuable time with us. I hope the relationship between not only India and US, between us, Wings of Aero
Yes.
and your organization will continue that relationship in future also. Surely we
So,
will.
sir, I would request you. We can have a few more interactions also.
My pleasure. Yes,
It
it's a
should
great
not be.
honor.
It should not be last one. It should be beginning of our journey.
Let's do that.
Yes,
Yes.
sir.
Yes.
Once everything COVID-19 situation is become normal, we will invite you to India. So India will meet you surely.
I would
Take
like that
care.
very much.
Take care and stay safe, sir.
Yes, you too. Thank you.
Okay, sir.
Thank you.
Okay.
Goodbye,
So,
everybody.
yes, sir. Goodbye, sir. Goodbye. With this, we are signing off, sir. Thank you.